In our proof that the derivative of sine was cosine, we came up with two very important limits. The first limit was the limit as theta goes to 0 of sine of theta over theta was equal to something. What was that limit equal to? Do you remember? It was equal to 1. We had a second limit, and that was the limit as theta goes to 0 of cosine of theta minus 1 over theta was equal to, and that came out to be 0. Everybody okay with that? All right. One other thing I need to remind you of in this lesson is just that if you were to take 2 over 3 and multiply it by 3 over 2, everybody agree that that makes 1? Okay, and you could actually exchange these using the commutative property of multiplication. You could write this as 2 over 2 times 3 over 3. So everybody see that the commutative property of multiplication allows us to move the 2 and the 3 back and forth? That's completely legal. As long as you know these three pieces, we can then identify these type of limits here. So here it says evaluate the following limits. Limit as theta goes to 0, we want to go through these 4 problems today. Limit as theta goes to 0 of sine of 2 theta over theta. The first thing we always want to do is try to plug in 0 to see what we come up with. And if we plug in 0, what is the sine of 0? Need to review that. Very good. So if I look at the unit circle and I consider 0 degrees or 0 radians, the terminal point there is 1, 0. Is sine the x value or the y value? The y value. So therefore the sine of 0 is 0. So I get 0 on the top, and what do we get on the bottom? We get 0. So that's an indeterminate value. How do we try to figure out what that value is? Well, we're going to use this piece right up here. And notice that I have a 2 theta as my angle. So I want the same angle that I'm taking the sine of as I have in the bottom. And so what I'm going to do is I'm going to do a little trick here. I'm going to say the limit as theta goes to 0 of sine of 2 theta over theta. Okay. And I am going to multiply the top and bottom by 2. And the reason why I'm going to do that is because I want to create a 2 theta in the bottom. And now that I do that, I get the limit as theta goes to 0 of sine of 2 theta over, I'm going to put the 2 with the theta, times 2 over, if I move the 2 over by the theta, what do I have right here then? A 1. According to what we had just done earlier with this limit right there, you can see that if you have a sine of an angle over that same angle, the limit is equal to 1. Notice sine of that angle over the same angle, this limit is 1. And so I get 1 times 2 is 2. And 2 is my answer. I have my next one. I have the limit as theta goes to 0 of sine of 3 theta over 5 theta. And I don't have the same angle on the top as I do in the bottom. What angle do I want in the bottom instead of 5 theta? I want 3 theta. So let's multiply the top and bottom by 3. And if I do that, I can then write the limit as theta goes to 0 of sine of 3 theta over, I'm going to exchange those two using the commutative property of multiplication. So what do I get in the bottom? 3 theta times what's left? 3 over 5. What is this limit? 1 times 3/5 is 3/5.
That's amazing.
Yeah. You know, the whole idea is we're trying to, again, figure out ways to deal with this indeterminate value. We do have other ways of dealing with it, that you'll find out later in this course. But this is one that I'll admit, people go off to college, and if they redo a Calculus 1 course, the professors start doing this, and people get really confused. And so we spend one day on it. It's not too bad. But let's look at problems that are just slightly more challenging. We have the limit as theta goes to 0 of cosine of theta minus 1 over sine of theta. I should always plug in my 0 value to see what I get. What is the cosine of 0? 1 minus 1 is 0. So I get 0 on the top, and then the sine of 0 is, so I get 0 on the bottom. So notice that 0 over 0 is an indeterminate value, and that's what we want to try to figure out. Notice in this situation, I have cosine of theta minus 1, but it's not over theta, is it? If I had a theta in the denominator, that would help me out. Because look, in this situation, I have cosine of theta minus 1 over theta. That produces a value that I know. So I'm going to rewrite this as follows. I'm going to do a little trick here. I'm going to write as cosine of theta minus 1 over 1. And I'm going to multiply that by 1 over the sine of theta. So I just split it apart into two fractions. Now, what do I want in the bottom here? I want theta. So what should I multiply by? Theta over theta. Let's consider the 1 over the sine of theta. That's very similar to sine of theta over theta, isn't it? If I put this theta here, I'll have theta over the sine of theta, which will just be the reciprocal. And what's the reciprocal of 1? 1. So you can see that that's going to work out quite nicely as well. So I can rewrite this, the limit, as theta goes to 0 of cosine of theta minus 1 over theta. So I pulled this theta over here times theta over sine of theta. Remember that this first limit, cosine of theta minus 1 over theta, is what? 0. And that the second one is 1. And that multiplies to 0. And finally, we have this last one. What I would like you to do is I would like you to see if you could take a minute, minute and a half, and work with your partner and see what happens when you plug in 0. Can you come up with the cotangent of 0 and the cosine of 0? Think about it together. Use some of your trig knowledge, and we'll talk about it together. See what you come up with. Go.
So we have to multiply by 1 sine of 0 over 1 over 0 divided by cosine 0, which is what? 0 divided by what? So 0? So 0. So 0. Right. You just have to get that 0 over 0. So that's 0.
No, because like you're supposed to like.
That's it.
Yeah.
I don't think we died.
Oh, it's cotangent versus
Hey, my tummy hurts. Really? Yeah.
No, I'm not.
Oh, yeah. Wait, do you want to go on a race tomorrow against me?
What?
on a golf course.
I don't know, like, should we race, like, run? Or should we
Okay.
race exercise?
Let's take a gander here. First of all, let's look at the bottom. What is the cosine of 0? It is 1. So everybody agree we're not going to get 0 over 0? So this is not an indeterminate situation. Look at the top, cotangent. Well, tangent is going to be your y value divided by your x value. But cotangent is your x value divided by your y value. And if you have your x value divided by your y value, what's 1 divided by 0? Undefined.
Ooh.
So this is not a 0 over 0 situation. This is a much more challenging limit to try to find. In fact, we don't really have a lot of capabilities of doing this right now other than just typing our calculator and taking some random guesses by approaching values, okay? But I have this here because I want you guys to understand that you need to plug in 0. Don't just assume that just because you have trig stuff, it's like, oh, it's going to be 1 and 0. It's not always the case, okay? So let's change the problem to be one that is going to model a little bit more what you need to know for your assignment. That'll be the limit as x goes to 0 of the tangent of 5x over the sine of 2x. That's a good problem. We've already talked about it. What is the tangent of 0? Y divided by x would give you 0. And what is the sine of 2x? Or sine of 0? Sine of 0 is 0.
Yes.
Sine is the y value. And so we get 0 divided by 0, which is an indeterminate value. Now, notice that we have a tangent in here. I don't know much about tangent, but I do know something about sine and cosine. So what could you do?
Split the tangent and cosine. Sine.
Tangent specifically is equal to
Sine over cosine.
sine divided by cosine. So I'm going to write this, the limit as x goes to 0 of the sine of 5x divided by the cosine of 5x, all divided by sine of 2x over 1.
Oh dear.
I now face a complex fraction. What should I do? And I get the limit as x goes to 0 of sine of 5x over the cosine of 5x times 1 over the sine of 2x.
Wait, why was the first one? Oh, wait, never mind.
Good, Jacob?
Yep.
Now I want you to be able to understand what's causing a problem here. Stop thinking about problem recognition and just like, what am I supposed to do when? Start understanding what the actual issue is. What is the cosine of 0? 1. So the cosine of 5x is not causing any problem at all. That's not what's producing 0 in the denominator, is it? But sine of 0 is. So this is the part that's causing an issue, okay? What I would like to see is instead of a 1 over the sine of 2x, what would I like to see in the numerator instead? A 2x. I'd like to see a 2x, right? And what if instead of sine of 5x over cosine of 5x, what if I had sine of 5x over 5x? Okay, so I'm going to separate this into the limit as x goes to 0 of, I have sine of 5x over 1 times 1 over the sine of 2x times what remains? 1 over the cosine of 5x. Everybody okay with me splitting it that way? And now you told me, what do you want here? A 5x. So I'm going to multiply the top and bottom by a 5x. And what do you want in the numerator here? A 2x. I'm going to multiply the top and bottom just by 2.
Just by 2.
Because I already got my x right there, don't I? See that? And so now, as I write it, I have the limit as x goes to 0 of sine of 5x over what? 5x. I'm going to be careful on my work, so I'm going to go ahead and cross off things as I use it. I've used the sine of 5x and the 1 and the 5x. Those are all gone. Times what? 2x over sine of 2x. Good. I've used up the 2 in the x and the sine of 2x in that one. Times 1 over the cosine of 5x times 5 over 2 is what remains. What is that limit? 1. What's that limit? 1. What's the cosine of 0? And 1 over 1 is? 1 times 5 halves is 5 halves.
Wow, that was a lot.
4 problems on the day you get back. It is a lot of work. So you guys can go ahead and grab your homework. Viv is already done with her motion stuff and her derivatives of trigonometric functions. She's going to look at this one which says special trigonometric limits. Okay, special trigonometric limits. These should go fairly fast. For example, the first one, you can simply multiply top and bottom by 5. And you should be able to work that through, okay? I'll get the answer key out, ready to go. You guys have about 5 minutes. You can probably get the front half of this done. I believe in you, Rosa. I believe in you. You can do it.
Put up. Put up. Just this one.
Gotta go right back to that.
Isn't that Trig really nice?